This is the destination MAC and source MAC in the second layer. And checksum. Then the overall tag is embedded in the overall data frame. The tag is not just a VLAN ID. It contains a lot. But these things are not very important. First there is a TPID. It represents the 802.1 queue we will talk about today. 802.1 queue is also called .1 queue. We will configure this thing when we do configuration today. It is a data encapsulation standard. Is a type of publicized tag. Cisco actually has its own proprietary, called ISL. But we hardly use this now. In fact, the proprietary technologies of various manufacturers are not used very much. We are now using public. So it identifies the what kind of tag type do we use. Further down here there is a priority. It represents the priority of VLAN data. In the future, you will learn the IE stage. Learn this field when you learn QoS. Let's not look at this stage. Further down is CFI. It represents whether this frame is a standard format. A CFI of 0 represents the classic format. A CFI of 1 represents a non-classic format. It's almost classic now. So we don't need to look at these parameters now. The most critical is this VLAN ID. This is the switch. This is a PC. PC sends a data. When the data arrives at the switch interface, the PC will carry the VLAN ID. Then there is a 12B written in the VLAN ID. Represents 12 bits. VLAN ID has a range. 12 in total. Each bit has two values 0 and 1. This represents the number of VLANs you can create on the switch. You divide an interface into a VLAN. A data enters this interface. Enter the corresponding VLAN ID. This VLAN has a range. Each bit has two values 0 and 1. There are 12 bits. A total of 2 to the 12th power. A total of 4096 combinations. That is a total of 4096 VLANs. But 0 to 4095. This is a total of 4096. Start from 0. Computer languages start with all zeros by default. So it ranges from 0 to 4095. Among them, 0 and 4095 cannot be used. The VLANs we can create are 1 to 4094. This is the range of VLANs we are able to use and create. Remember this. You have no way to create a VLAN larger than 4094. In addition to the VLAN ID we mentioned above, there is another concept. Link type. Let's go back to this picture. For example, we are not giving this device an IP address now, regardless of whether it is a network segment. Assume now go through layer 2 communication. The data arrives at the switch here. Since the behavior of this tag is done by the switch, then think about it. It sends this data to the PC on the right with this tag. Assuming they are both in the same VLAN. Can you send it over? Okay. This is not allowed. Let's take a look at this picture. First you need to know. PC can't recognize tag. I had a student ask me a question before. PC does not recognize the tag. Then don't look at this field. Okay? Just skip it. What I want to say is, our equipment is not so smart. The data frame read by the device is 01010101. A normal data received by PC. After reading the destination MAC and source MAC, you should continue to read type. So if the device sends a data frame with tag, other devices will interpret the data frame according to the type. Then it will find that it does not understand. Because there are 2 bytes in the original type. The first 12 bytes have been read. The 2 bytes of type should be read. As a result, these 2 bytes have been read. It found that this does not seem to be type. Then it means that the data frame cannot be understood. If you don't understand, there is no way to read this data frame device. If it can't be recognized, it can only be thrown away directly. Because reading data is read one by one, including the type in the second floor of our study. The protocol in the 3 layers. It's all about pointing out what the upper layer is now. For the sake of, after reading the second floor, if the 3rd layer is the IP protocol, to read one by one field in the IP header, there are rules. So we often say, the lower layer indicates the upper layer, is for upper class service. When data is read, do you know what kind of data encapsulation standard to read the upper layer data? So this tag is sent to PC. It has no way to recognize. This packet can only be lost. Therefore, it cannot be sent to the PC with the tag. This thing is only recognized by the switch. I said it before. VLAN is deployed on the switch. Only the switch can recognize it. The router can also recognize. But you have to do other configuration. Today we will talk about how to configure. So what we should do is tag the data when it comes in. For example, type a tag 10. In the future, this interface will also be tag 10. Data to be sent. Then when the data leaves this interface, remove this tag 10. Equivalent to. You now want to identify whether the 2 of them are in the same VLAN. Then both interfaces belong to VLAN 10. Tag when you come in. Then when the data flows in the switch, it carries the tag. Remove the tag when you come out. Then send to the terminal, so that they can be dealt with accordingly. It is reasonable to be able to do this technology. Otherwise, the technique is useless. All I want to say is, after we divide the VLAN, each interface will have its own link type. Different link types have different processing behaviors for data. Let's talk one by one. In fact, Cisco is better understood. Cisco only has 2 link types. The first is access mode. Access mode is used to connect to PC. Before talking about access mode, I should mention 2 other things. First of all, you need to know the data frame sent by the PC is called the original frame. It has many names. The original frame is also called the blank data frame. Means data frame without tag. The data frame sent by the PC is always a data frame without tag. For switches, the switch will be flooding. The flooding principle of the switch will be on all except the receiving port. Flooding of other ports belonging to this VLAN. We just said, the switch receives data if flooding. Then it is all interface flooding. Because all interfaces are in the same VLAN by default, called VLAN 1. If the VLAN is divided in the future, an interface has received a data. For example, this unknown unicast is a broadcast. It will only flood the ports belonging to this VLAN. As for how to configure the port VLAN, we will demonstrate. For access mode, we'll connect some end devices, such as computer, server, printer, camera, etc., including future dedocking routers. In fact, we use the most access mode, because the router is a layer 3 port by default. It also cannot handle VLAN-related content.